Our learning goal, let's go over here. Our learning goal today states, Danny, are you with me? Celia, are you with me? Okay. I can graph more than one set of values on a number line. So today they're going to give us compound inequalities that are going to have an OR situation in them. And when there's an OR situation, that means both of them are going to be combined onto the same number line. In other words, we can pick a number from one of them or the other. It doesn't have to be an AND where they satisfy both of them, but instead we say, okay, we're going to graph one set. One of them is going to be a compound inequality. The other one's going to be a simple inequality, and we're going to combine them on the number line. So it's kind of like when a parent or someone says to you, you have a choice of two chores. You can either clean your room or you can unload the dishwasher. Well, if your room is a huge disaster, I'm going to guess you're going to probably choose to unload the dishwasher, right? Might be a better choice, but you get to choose one or the other. They're both on the table for you. They're saying, here's your choices, you get to pick. So this is going to be kind of like the same thing. We can pick from one or the other. So in activity 1 here it says, for each of the problems, show the two sets of values that are possible answers for the inequality on the number line. So notice right here, there's that word OR. Will you circle that word OR in there? But be able to still see the inequalities that are involved. So this whole statement would still be considered a compound inequality. And within this compound inequality, we have this one right here, which is that itself is a compound AND inequality. This one we would call a simple inequality. So we have all kinds of things going on here. We actually have 3 endpoints. So we're going to just deal with one of them at a time. So let's look at this first one right here. We have 5 is less than x, and x is less than 10. And ones mean it has to satisfy both conditions. It has to be less than 10, and it has to be greater than 5. So we're going to put a circle at 5, circle at 10. Do we shade those in? Are they part of this inequality? Why not? We don't have that equal to bar there, do we? Okay. And where are we going to shade this? What numbers are greater than 5, but also at the same time less than 10? Caden?
The numbers in between.
All those numbers in between, yeah, all those numbers in between satisfy that compound inequality in our OR statement. Then we have the simple inequality that only has one endpoint, and that endpoint is at 12. So we'll put an endpoint at 12. Are we going to shade it in?
Yes.
Is 12 included? No, so we're not going to shade it in, and it says x is what? What does that symbol say? It is greater than, so we need to shade which direction? Left? Right?
Right.
To the right. The number is greater than 12, go this direction, and we're going to stick a shaded in arrow at the end of it also. Okay. So now basically any number between 5 and 10, and any number bigger than 12 gets to be considered a member of this solution set, this set of values. Okay, so I want you to try the next one on your own. You try number 2. Graph this combined set of values on that number line. Okay, can anybody share with me what I should do? Or at least start me out? Wait,
Put a circle on
on one, positive one?
negative one,
Oh, negative one, okay.
and then shape it in.
shaded in,
And
okay?
then put a circle on number 3 and don't shade it
On 3 and shaded in?
Don't.
Don't shade it in,
in. And
okay.
then shade.
Okay, and then shade in between those two, you said, okay? And that satisfies the first part, right? Our compound and inequality, that's an and one. Okay, somebody else finish it up for me, please. Ikea? Shaded in or not?
Shaded.
Shaded, okay. And
It goes to the right.
it goes to the right, so all numbers greater than 5 should be shaded also. Anybody want to challenge any part of that? Just, are we good? You got it? Okay. How about this next one? Circle at 20. Circle at 40. Shade them in. Shade one of them in. Don't shade either of them in.
Shade both of them.
Shade them both in, okay? Because both of those inequality symbols have what? The equal to part. Where else are we going to shade? What other numbers qualify? Harley? Okay, I'm not finished with this one, I don't think. Shaded in between, okay. Like barbells. Okay. Okay, now Harley, do you want to finish it for me?
So the circle on 16, don't shade it in.
Okay.
Shade in from 60 to the right.
Shade in from 60 to the right, okay. Okay, now, what's going to happen in this next set of things that we're going to do, now the question is going to be, they're going to give us a value, and they're going to say, would it make this true? So give me in number 3, somebody give me a value that would make that combined inequality we've got going on true. Give me a value that would make it true. Number 3. You only know how to shade, huh? Oh, we're good at that. Okay, well, let's master this then. What values get to be considered solutions that would make one part or the other true? Danny? So you're looking at this 30 right here, right? Is that what I heard? Okay. So 20 is less than 30, right? So if we put a 30 in here, basically she's saying if I stick a 30 in there, is it true? Is 20 less than 30? Yes. Is 30 less than 40? Yes, so it makes that one true. Does it make this one true? If I stuck it in this one, would it make that one true?
No.
Is 30 greater than 60? No, but does it have to be? No, because it's an or. It says make one of these guys happy. You don't have to worry about both of them. You have a choice. Which one does it satisfy? So it satisfies the first one. Okay, so that's what we're going to be doing down in our next group here. It says tell whether the number is in the set of possible values, circle true or false. Well, we're not only going to circle true or false, but of course we're going to support it with a graph. Which part of it does it make true? Okay? So, or false. Or what's the reason it doesn't? 10 is in the set of values. What do you think? True or false? Well, we're going to look at this one right here. You think, let's graph that. Let's just graph these separate, okay? Let's just do this so we don't have to make such fancy number lines. Okay, so you'll notice on the answer keys that you've been doing my graphs, I don't have all those extra things in there. I just have the endpoints. So 5 and 11 are the endpoints. Or at least I think it's 5. I kind of wrote over it, so I'm not sure. Yeah, okay. And are they included? Should either of those circles be shaded in? No, okay. And where would I shade? Right in the middle, right between them. Okay. Let's do the other one also. Let's just do like I said, let's just do them separate of each other. So we can not have to be quite so detailed with our number lines. So it's kind of like these guys are together. There's an or between them. Put the word or between them. Should 25 be shaded? Should that circle be shaded in? No? Which way should I shade?
Right.
To the right. Okay. So the question is 10 in the set of values? Is it in there? Yeah. Which one? The first number line or the second one? It's in this first one here, isn't it? Wouldn't it be about right there? Yeah, so 10 is in the set of values, true. It's in this one, so let's just put kind of like a little tick mark there and put a 10 so we can show this is our support. Okay, let's try the next one. It says -4 is less than y, and y is less than 4. So let's just graph that right away. So there's our one that has two endpoints, -4 and +4, in the correct order on the number line. Circles at both of them. Shade those circles in. Shade one of them in. Oh, no, don't shade either of them in. Okay, and where should we shade? In the middle, in between them. Okay. And then the other one says, or, our other one is a simple inequality. It only has one endpoint. Is 10 going to be shaded in? No? Okay, and we're going to shade to the right. Okay. Well, now that we have our graph set up, that should make it easier for us to check to see if 4 is in the set of values. Okay, is 4 in this set of values, this first one? Is 4 shaded in this one? No. How about over here? Would it be in here? No. So this one is false. 4 is not in our set of values. It's one of the endpoints, but not an endpoint that is shaded. So it does not get to be counted as one of the values in the set. Okay, you try the next one on your own. So how are you feeling about number 3? Is that one a true statement or a false statement? True or false? Tyler was saying false. Anybody want to agree with him? Yeah, some of us do. Because it's asking us about 12. Where's 12 at? Well, it's right here. Is 12 included in that one? No. Where's 12 at in this one? Well, it would be over here to the left somewhere, wouldn't it? It's not in the shaded region there either, so it is false, isn't it? Okay. How about our next one? 5 is in the set of values. Well, first thing we're going to do is we're going to graph. And check it out by a graph supporting our answer. True or false? Which one is it satisfied? The first one or the second one? Yeah, the first one. So it's right here, and it's shaded in. So the answer is true. Okay, and one more. We have notice something about this one. Sometimes we get caught, we just automatically think either both endpoints will be open or both will be shaded, but in this last one, that one's not the case. How do you feel about this one? 35 is in the set of values. True or false?
True.
True? Okay, so 35 is somewhere between 15 and 25? Oh. Well, but since it's an or, does it satisfy the second one then? Yeah, we could say it's probably something like right there. It's in the shaded region, isn't it? So we would say true. One or the other. It has to be one or the other. Their shaded part, and then it needs to say it is a member of that set. Okay, questions on that? You can do that on your homework. Okay, let's go to the back side. Look familiar?
Yep.
From what? Workbook, what you were just doing at the beginning of class, so now we're going to check you out and see how you did, okay? Select the compound inequality that matches the word statement in each problem. Well, guess what I'm going to suggest we do? Graph them. So let's just get ready. The low temperature for the day was -5 degrees Fahrenheit, and the high temperature was 15 degrees Fahrenheit. Show the temperature T using a compound inequality. So, sounds like our endpoints are -5 and 15. Was it ever -5? The low temperature of the day was -5 degrees Fahrenheit. So it was 5 below, wasn't it? Okay, so we put a shaded circle there. The high temperature for the day, was it ever 15 degrees?
Yeah.
Yes, at one point it was 15 degrees. That was the highest it went though. And where would all the other temperatures be? In the middle of those two. Okay, so now we need the inequality statement that matches that number line graph. T in the middle, because all of the shaded part is T, and -5 at the left end, and +15 at the right end. And should the equal to bars be there?
Yes.
For both of them?
Yes.
For both ends? Oh, okay, well that's easy enough. I'm going to look for the one that has both equal to bars, because everything else about them is exactly the same, right? They both have -5 at the left end and 15 at the right end. They both have T in the middle. They both have the is less than, is less than. Is less than, is less than. Is less than, is less than. But they don't all have both the equal to bars. So did you get it right on your own? The first one? Okay. Let's go to the next one. Children in Kitty's Fun Playland must be at least 2 and less than 8. So, if I have a 2-year-old grandchild, can I take him in this playland?
Yes.
Okay. If I have an 8-year-old grandchild, which I happen to have both of these, a 2 and an 8-year-old, so can that 8-year-old go in there? No, because what does it say? Less than 8. Oh, I'm sorry, Truman and Aubrey, you don't get to go. But Emily does. And maybe Monty does. We'll see. Monty's 5. I wonder if he gets to go. Does Monty get to go? Yeah, because Monty's 5 and it says at least 2. At least means that's the smallest number and we go beyond it. But less than 8. And so that's going to be our age range of kiddos that can go in there, okay? So we need a 2 at the left end, an 8 at the right end. Oh, look at there, every one of those has that. We need an A in the middle to show the ages, because this is showing all the ages. And then we need, they're all is less than, is less than, is less than, is less than. What do we need to look for? Harley?
The equal sign with the 2.
The equal sign on the one at the end with the 2, and the other one should or should not have the equal sign. Not, because it's open. So which one is that? C. There's our answer right there. That's our compound inequality. So graphing at first, I think is so much easier to do from a graph than it is to do it without the graph. Anybody agree with me? A couple people. Okay, if you did not graph number 3 the first time, when you were working it the first time in your workbook, I want you to do it right now on your notes. Graph this next one, number 3. Go ahead and get a graph. What do you think the graph would be? We've had a little bit of trouble with problems like this on our quizzes. Did somebody score a 53?
Yes.
Yes. Did somebody score a 99? Yes. Okay, well then we need to shade those both in. I'm not going to leave those people out. They're part of the scores. Well, that's 53 is the lowest and 99 is the highest. Everybody else must have scored somewhere in between, right? Okay, so what's our answer? B. Yeah, it is right there. And one more, we'll check you out and see how you did on the last one if you got to it. Okay, we will put a number line graph first though. At the family reunion, the youngest grandchild was 5, and the oldest grandparent was 87. Show the ages A using a compound inequality. Well, we're also going to show it with a graph for our compound inequality. Was there somebody age 5? Yeah. Was there somebody age 87?
Yes.
Yes. And everybody else was
In the middle.
in between there. Yep. Okay. So what's our answer for this one? Answer B. We need the equal to bars at both ends, don't we? Both of them were shaded in. Okay. Check yourself out. If you got it done, did you get it right? Okay. Any questions? Okay, the notes are for you to keep, the workbooks are gonna get returned, but we're not gonna all go back and return at the same time. So it looks like Mrs. Allen is gonna be willing to pick up and put away. Pass them to the back for them, thank you. And